Yep. Alrighty, gang. Well, again, my name's Alan Colmer. I'm the local account manager for Welltec, based out of Cranberry, Pennsylvania, near Pittsburgh. Basically, an account manager is a nice way of saying I'm a sales guy. I sell people stuff. Basically, our services. So, at any rate, that's all right. So Welltec's a privately owned company. I don't really need it that much. I'll just move around a lot. They'll be able to see around me. All right. So we like to start everything off with a safety moment. Essentially what this is showing exactly what you never want to do. This guy was up on the monkey boards of a rig. He's not even using his lifting harness. He's literally on the verge of dying right there, right? He probably fell asleep from a long shift. He, luckily enough, was not a big old boy like me, so he was able to hold on real tight to the traveling block there and not manage to fall to his death. He lived through this, by the way. But the point of all this is that safety and environmentalism is paramount within the industry. Whenever you first go to work, wherever it is that you're going to end up working, the first thing you're going to do is undergo safety training. I started out at one of the largest oil field companies in the world, Schlumberger. The first thing they do is they send you to a school and train you how to drive again, because car accidents, motor vehicle accidents were the #1 cause of death for all the employees worldwide. So most companies have a safety program. The biggest trend in the industry is everything's behavior-based safety program. So they don't want you to just make a checklist and check off the checklist and say, I did my safety checklist. They want you to modify your working lifestyle to be thinking in terms of safety, and it works, right? Because all the safety principles are based on nobody ever thinks an accident's going to happen. That's why they're called accidents, and it's too late to be prepared once it does happen, right? And it gets ingrained in you, and they want to develop a culture of safety within the industry. So now what we're going to do is we're going to go ahead and hop into the primary technology Welltec is most famous for. What Welltec is most famous for is a well tractor, which is represented here. A well tractor is a downhole tool that is basically used to pick up wireline and deliver that into the lateral. When you're drilling a horizontal well, gravity will get you down into the curve of the well, but if you want to get out into the lateral, there's only a couple different ways you can get tools out into the lateral. The traditional way of doing things is you would take a 40-foot joint of pipe, you would put one pipe in the side of the other pipe, push it down, put another 40-foot joint on, push it down, 40 feet at a time for up to 30,000 feet, takes days, okay? Then people invented coil tubing. Coil tubing you can run in hole. It's a continuous reel of tubing that you can run in hole at 100, 200 feet per minute. That sped things up, but it's very heavy. There's a lot of heavy lifting involved, a lot of fluids required and things like that. So we created a system to be able to do it off of a wire line. So basically we attach a wire line fixture on here. We have an electronic section that drives a hydraulic section. It's an inline piston pump that drives the tool. All these wheels and arms are actually spring-loaded closed. They're only showed open and activated here for presentation purposes. So they're spring-loaded closed. We have to generate enough force to overcome the spring for the wheels and arms to come out, and then they spin. And we attach the wireline tools at the end, and we push perforating guns, logging tools, microseismic arrays, pipe recovery tools, anything out into the lateral, all off a wireline. The advantage of that is it's safer, easier, faster, usually more cost-effective than the old traditional way of doing things. This is a video that shows a well tractor, how it operates, going through a restriction in the well. So the tool is designed to where if you have different size casings, you have patches in the well, any kind of anomaly in the well, the tractor can navigate that and not get hung up, which is one of the largest issues in the industry is you lost something in somebody's well. There's millions and millions of dollars on the line, and people tend to get very upset over these types of issues. what's literally called fishing. So you lose something in their well, you've got to go fishing for it. It's not always that easy. You literally, if you work in the industry long enough, whether it's on a frac site, a drilling rig, or whatever the situation is, you are literally going to witness the impossible occur. It happens daily. It's never supposed to happen. It shouldn't happen. We just saw it happen right here and now, all right? So these are the specifications for our newest generation of well tractor. We're owned by one guy in Copenhagen, Denmark. He's a geoscientist by training. He was working offshore, helping people develop ways to pull these tubes, coil tubing uphill with fluid. He said there's got to be a way to do this off of this electric wire line. He created the robotic well tractor. Statoil saw it up front, gave him like $6 million of startup money and brought in a manufacturing firm. He developed it, right? First generation could only do about 20 feet per minute. We're on our third generation of well tractor right now. We can do around up to 70 feet per minute. Our newest generation of well tractor that's running in the North Sea right now, going through its paces, is a little bit smaller and faster, and it can go up to 100 to 120 feet per minute, which is a pretty large step up, getting much more competitive with coil tubing and its speed. This is a case story showing the largest, the deepest well and the longest lateral we've been in locally in the Northeast. This is in the Utica well. It's just under a 24,000 foot well with an over 13,600 foot lateral. We conveyed 5 guns and a plug to the second stage in the well because they couldn't pump into that. And we conveyed it across the 13,000 foot lateral without issue. As the industry it used to be that people only drilled wells that were 12,500 feet deep with a 5,000 foot lateral. That's nothing anymore. Everybody's drilling out 18, 20, 25,000 feet. Right now in the Northeast, people are drilling 30,000 foot wells. Everybody's trying to beat Eclipse Resources and their longest wells ever drilled on land operations. So there are challenges involved, such as everybody uses 9/32 wire line. That is too light right now. As you get out to 25,000 feet, just the natural weight of the wire line and the tools itself, you're compromising the safe working load of that wire line. People are ultimately going to have to size up the size of the wire line. But at any rate, the world record lateral distance for our technology, the well tractor, occurred in the United Arab Emirates. It was a well with a 19,596 foot lateral and a 27,700 foot MD, measured depth, the total distance that it goes. So we were able to convey a 130 foot long production logging tool string. We did have to use a tandem tractor setup. So our standard tractor has one motor, can generate 1,000, 1,200, 1,400 pounds of pulling force. We can use a second motor to get more power and force out of that and generate up to 2,200 pounds of pulling force. A tandem well tractor was used on this to deliver those tools to that depth because you needed a larger wire line, 5/16 wire line, which is much larger and heavier. This is a representation of drag modeling that we have. So we have a MATLAB-based drag model that basically forecasts how feasible the job is with our technology. Because the big thing within the industry is if you want to stay in business, you never show up on location and say, we can't do this job. That's impossible. We can't do it. They don't like to hear that. You wasted everyone's time and money. You'll never work for that company again for a long time. So you have to be able to go out there. And even as a salesperson, one of the first things you learn as a sales guy, don't lie. Never lie. If you lie, they will never trust you again the rest of their life. Never. Okay? And you can have a great relationship with someone for 5 to 10 years. You tell them one lie and it's over, and they'll never trust you again. So the industry is all about transparency, being upfront. If you can do the work, come out here and do it. If you can't do the work, don't jerk me around. Tell me you can't do it. We'll find another way to do it, and nobody gets any hurt feelings, right? So that's why everybody has job modeling. This particular operation was a classic situation of what's never supposed to happen. The simple mistake in this particular pad was this particular well operator, they got the names on their wells confused. One well is 20,000 foot deep, one's 17,000 feet deep. They named the one that's 17,000 feet deep, the one that's supposed to be 20,000 feet deep. They got it confused. So lo and behold, they go out and they start fracturing this well. And then after they start getting into the zipper frac on this well, they realize that there's something going on. There's some problem here. So we actually ran a camera logging tool to help determine it's just a naming convention. We're in a different well than we thought we were. And long story short, they left 4,000 feet of lateral, not fracked, just they had already started fracking, and below they had 4,000 foot of well that's just doing nothing. So what they had to do is they had to go in, they had to run 20 stages of perforating guns. Time was of an essence because essentially what they needed to do is they needed to plug off all the fractured zones that were above this 4,000 foot lateral section. So they had to pump a chemical diverter to do that. Chemical diverters break down as a function of time and temperature. So time was of an essence. It's a very deep well, just under 22,000 feet deep with an 11,500 foot lateral. They could use a coiled tubing unit, but it's not going to be able to get out past 18,000 feet. So they're very limited in that. It's because of frictional drag. It can't get that deep, right? Snubbing units can get that far because they have a hydraulic assist to get the pipe down, but it takes forever to do it, 2 or 3 days sometimes to get to 22,000 feet. So we're able to come out, get down to 22,000 feet within a matter of 4 to 6 hours or less from being on location. We ran in nine runs over the course of under 4 days, and it really only took 4 days because they had some other operations going on in between all of our runs. But we ran 9 runs conveying 88,000 feet in the 9 runs, nearly 17 miles in under 4 days, right? And we could have easily done it probably in about 2 days to do that distance. So it was all good, very impressive. Operations in general. As a matter of fact, whenever we were getting involved in this project, half of the engineers in the room for this operator were just like, you guys are nuts. It's not going to work. It's just a tractor. It's good for 1 or 2 runs, right? I'm not sure we can go out here and make 10 or 12 runs. But we had done it before. We had some case stories, so it's not the first time. So the advantage of a tractor is, and it really is revolutionary technology, right? I mean, the owner of our company is forward thinking in every way. And I was explaining this to the professors earlier. The guy who owns our company, he's been offered hundreds of millions of dollars to sell out by every major oil field service company you've ever heard of, right? They've offered him a ton of money, hundreds of millions of dollars. He's laughed at them, refused it, and walked out the door because he's got other inventions. This is our oldest technology we're talking about. The newest technology we have is even more revolutionary, and some of the stuff they don't even tell guys like me because they're very secretive about their technology. But the value proposition is that a coiled tubing unit is a very large, heavy piece of equipment. We deliver our equipment on one pickup truck with a tow behind generator. The tool weighs around 400 pounds, 17 feet long, right? So you need a wireline truck and a pickup truck, that's it. A coiled tubing unit is a semi with a giant spool of coiled tubing the size of half of this room. I mean, it's a drum that's 10 feet in diameter tall, wrapped with 30,000 pounds of coiled tubing around it or more. So you have that semi, you have like 3 other support semis. So to get coiled tubing out on location, you're talking 4 semis, a huge footprint on location. We can do the same work off of a pickup truck and wireline unit, right? So that's very advantageous for various different reasons. Now, it requires less people, so there's less chance people are going to get hurt. There's a more clear communication of chain of command. This is your job, go do it. No confusion in between. There's a lot less heavy lifting involved. We have a much smaller CO2 footprint because all the coiled tubing units are ran by diesel engines. So you're burning diesel 24/7 the entire time it's running. Ours, we have a very small gas-powered, diesel-powered generator. It's not producing nearly as much emissions. And then a lot of people are using field gas, natural gas directly from the wells to power generators for power on location and things like that. And then we're generally less expensive than all the other alternatives, and we're faster. So people like it. And a key is no fluids are required. We require 0 water to do our operations, right? When you're doing a coiled tubing operation, you're using sometimes millions of gallons of water, right, to clean out a well. We can go clean out the same amount of debris using 0 water. And that's where we're getting into the cleaning tools. This is a representation of our power suction tool, the PST tool. Basically, the way it works out is, if you ever happen to have worked around any oil field stuff at all, there are things called cement dump bellers where you run in, you can dump stuff out of the tool into the well. This works opposite, right? We have a pump inside a tool. It creates a vacuum, right? A Venturi effect, circulating fluid through that tool, and we suction debris into our tool, and then we can hold it in there, right? This is an advantage. It's a small volume cleaning solution, but it's an advantage over some operations because we can deliver the material directly back to the surface. We have tools that have a bit on the end like this that can mill and vacuum suction the debris in. This is all very small volume cleaning work. Now, this is where the nuance comes in. We can't go out and do everything coil tubing and these other heavier weight operations to do. We're never going to claim that we can. We can't go out and effectively clean 1,500 feet of sand in a lateral. It's going to take a long time. So in those operations, coil tubing or stick pipe, as they call it, just regular tubing, is generally much more beneficial. But the next video shows a slide of a well that was cleaned out with coil tubing. So we'll see if we can get the volume going here.
The wellbore fluids were a mix of produced oil, produced water, and frac water.
So let me Yes, so this was a well that was cleaned with coil tubing. This was a camera ran on coil tubing after coil tubing had already cleaned the well, right? And you can see that there's a great deal of debris still left in the well. Our technology has the option to be able to clean a lot of this out because it's really funny. You have coil tubing guys who are like, okay, I'm going to go out there, I'm going to use coil tubing, I'm going to make your well squeaky clean. There's not going to be a drop of dirt left in your well, right? That's what a coil tubing salesman will tell somebody, right? And then, interestingly enough, 2 days later, the exact same coil tubing salesman will tell somebody, we couldn't possibly pump enough rate through our coil tubing to clean everything out of the well. That's why there's still stuff there, right? So at any rate, what you find is that, everything's not an exact science, right? There's limitations to what everything can do. And for example, a coil tubing unit, it's only 2 inches in diameter, right? The ID is actually going to be like 1 3/4 inches or something like that, 2 inches. So you can't pump enough fluid through there fast enough to power everything back up out of the well. You're going to have something left in the well, right? But our tool, the next video is a test loop of ours done in Norway. If anybody speaks Norwegian, let me know what these guys are saying. And it shows the power of our tool, vacuum suctioning. Basically, we did this to prove to clients that it works. They put a bunch of gravel, rocks, all kinds of stuff in the bottom of this test loop here. We've got our tool going through. Some of these rocks are 1 inch, 1.5 inches in diameter. We just vacuum suction it up in there. They were saying stop there. I figured that one out, by the way. So interestingly enough, this is one of the technologies that when I first started working for WellTech in 2010, selling in the Pittsburgh area, I had people tell me, you're nuts. There's no way on earth we would ever use that. And that lasted until about 4 years ago. When people first started drilling out past 18,000 feet over in the Utica Shale, for whatever reason, they designed a well in such a way they were counting on the toe sleeve and a pressure actuated toe sleeve to be able to pump tools down. Because as you guys have probably been told, until the well's open and you can start pumping stuff down, you're limited. You have to push it down with coil tubing or pipe or whatever, right? So at any rate, this particular operator, the toe sleeve didn't open, they couldn't get tools down. So coil tubing couldn't get through the lateral length and the depth. It would just lock up and never get there. A snubbing unit would be very expensive, take a long time, this type of thing. So we were the primary contingency and we were able to go in. First well, we just ran in with our well tractor. We shot the guns on the first stage. Everybody's happy. They're able to pump in later, start to frack. The second well, we tagged cement, junk cement, 4,000 feet high in the lateral. We pulled back out, ran back in with our milling tool, and one run in the milling tool, we were able to clear 3,000 lateral feet. Now that doesn't mean that we cleaned 3,000 solid feet of cement into our little tiny tool. That's impossible. But what you find is sometimes you just have a hump. You have one plug that's in the pipe that's stopping everything. Once you get through that plug, it's smooth sailing down below it. That was the case here. In one run, we cleaned 3,000 lateral feet of junk cement, which is just basically unset cement like that. And then the next run, we went back and cleaned 1,000 feet, got within 30 feet of the design depth. They said close enough, pulled back in, ran in with the guns, shot it, everybody's happy. So we were able to go out and make the 4 runs it took to get the job done in less than, in around 26 hours, barely more than 24 hours. If you did the same amount of runs with a snub unit or a stick pipe, as they call it, it would feasibly take you 4 days. And we were able to do it in just over 1 day. So they were thrilled about it. We were able to reduce their operations. So something that's really going to be working out here and has kind of a local effect to it is we also have what we call a dry environment cleaning tool, meaning that the vacuum suction tools I've shown you at this point, it needs a pipe full of fluid to create the vacuum suctioning effect to pull the debris in, right? There are a lot of dry gas wells out there that have zero fluid in them, and they don't want any fluid on them, right? As a matter of fact, up in northeastern PA, they have these old dry gas wells that were in horizontal wells that were drilled from 2008 to 2008 to 2010, 2012 time period. They want to clean those out to get the produced sand and shell out of them and get more production out of them. It doesn't make a difference how much fluid they pump into it. The formation is going to take every drop of fluid, and they're never going to get anything come back to the surface. They could pump a bazillion barrels of fluid into that. It's going to take it all, but they still want to clean it. So we, luckily enough, have a mechanical solution that can go in and mechanically clean all this produced sand and shell out with zero water, all right? So one of the biggest concerns that people have whenever you're dealing with urban drilling like you have around Pittsburgh and things like that, right? It's one thing whenever you're drilling a well 1,000 miles out in the middle of the desert and there's nobody around to see it. It's another thing when you're driving right through everybody's farm and backyard and all that stuff, right? So we reduced the heavy vehicle traffic. So we're able to go up to northeastern PA, clean this produced sand. We also find O-rings and rubber gaskets and parts of plugs and things left over from the frack in there. And we mechanically clean this sand and produced shell back out of the well, saving them millions of barrels of water, all the heavy vehicle traffic, the cost, the risk associated with it, which is a big deal. These are some of the features. Really the big key is that no fluids are used and things like that. This is what the tool looks like as it's operating. It's basically an auger-driven system, right? So the operator is ecstatic about this. This is kind of something we got into really just last year, and it all kind of came up by accident. I was at the client's office in Pittsburgh. We were talking about something completely different, and they were explaining to me they have this problem, right? And I said, well, hey, this problem you have, not being able to circulate fluid back to the surface, we've got a mechanical solution for it. And it's, kind of segued into, we're helping them save millions of barrels of water and heavy traffic and all this. And we'll ultimately write an SPE paper about it. We went back and we made some design modifications for our tool. This is the way the tool was originally driven. It had this paddle system and auger, and it worked. It was effective, but we all kind of wanted a little bit more out of it. So we redesigned the front end of the tool, and that's where the mechanical engineering experience came in to be able to work with the client and custom redesign the front end of the tool to best suit the particular operation. And that's one of the coolest things about working for a small company like Welltec is our owner, he has his little mad scientist manufacturing facility off to the side of all the main manufacturing facilities in Denmark. And we custom build tools regularly, right? So people come to us with a problem. They're like, we've got this problem. We want zero explosives on our platform because there's a bunch of pressure. We're afraid something's going to blow up. We create a solution that's all mechanical, no explosives involved. So we can also go in and fish So fishing is a very big deal, as mentioned. If you lose something down in somebody's well, millions of dollars are on the line, they want to get it out. People lose everything from bolts, gloves, pipe wrenches. Our tools occasionally get pulled off, the wire line breaks, and then you have to go fishing for the tool, right? We can actually fish our own tools, but we can also fish perforating guns. So we've been able to fish perforating guns out of the well, right? Be able to tractor in, latch into those, pull those out much more quickly than some other operations were. If you were to do that on stick pipe, it would be a much more involved process. This was something that occurred up in Tioga County. There's an SPE paper under this number written about it. Shell up in Tioga County managed to lose a plug setting mandrel, what's also known as a wireline adapter kit. It's right there. It's basically a plug that's used to isolate the well, right? Seal off the well and create a pressure seal in that well. It's all ballistically set. So you set off an electric charge or an explosive charge, and it strokes this mandrel and forces the plug to set. They lost it. Now some people just say, I'm leaving it down there. We'll pump it down to the bottom of the well and forget about it. Shell's not one of those companies. They decided they wanted to get this out, but you would typically try and pump a tool down to latch into it, but they couldn't do that in this case because they were running these flow-through plugs. If they pumped this back through the flow-through plug, they would never get it out. Kind of long story, maybe get into too many details or whatever. But at any rate, we're able to go in and use an electromagnetic fishing tool to tractor in, latch into this little tiny tool, that a coiled tubing unit. If you touch this with a coiled tubing unit, you're not even going to notice it. You'll never even notice that it's attached whatsoever. We're able to get a slight tension response, and surprisingly enough, we're able to pull this out in one run. So we tractored in, latched into it, pulled it out in one run, going very slowly, around 30 to 50 feet per minute on the way out. If you would have asked us, we even would have said it would take us at least 3 runs. We were able to do it in the first run. Pretty cool SPE paper about it. Now, we've won different awards, specifically with this event called the ICOTA, which is the International Coiled Tubing Intervention Association. So we've won a bunch of awards for them, specifically the well cutter tool. This is one of those custom designed tools. Somebody came to us, they wanted to cut a bunch of pipe on an offshore platform in Malaysia. They wanted 0 explosives on the platform. We created a way to do it, because ordinarily the way you cut pipe is you just put a shape charge in there and you blow it in half using explosives. It's the easiest, fastest, simple way to do it. Been doing it for decades, right? But it's a very violent process, very risky, and does damage to the steel. So we created the well cutter tool. So it centralizes itself in the pipe. Then these arms come out, and this is like a special composite alloy that's like diamond embedded, some kind of secret something, right? That basically it comes out and it grinds the steel in half, right? The driller's like this because whenever you use explosives and you just blow the pipe in half, then it leaves an uneven, jagged edge with bubbles, and it's very irregular in its shape. So when they go back in to try and latch onto that and pull it back out, they can't necessarily latch onto it very easily because you've got all this irregularities. So whenever we're finished cutting, it's a nice, smooth finish like that. And people like that because it makes it easier to fish. And there's no explosives used. We can cut through solid steel pipe that's an inch and a half, or half inch in thickness in as little as 10, 15 minutes. On the easy end. On the harder, denser steels, it might take 35, 45 minutes. But we can cut through it. We can make multiple cuts. We've also developed a little drill bit. You can just drill holes in the casing to alleviate pressure and stuff like that. So this slide just shows a demonstration of what we managed to cut. So it's one thing to say that you go in and you cut a piece of casing in half. Casing's just steel pipe. So it's one thing to say, I just cut a steel pipe in half. A lot of people can do that. But we're able to use this technology to cut what's called a packer in half, which is basically multiple layers of steel, rubber, all kinds of stuff. So we're able to make cuts at some of the biggest sections of the packer, which is not that easy to do. And then interestingly enough, we're getting into something called a torque plug, which is another ICOTA award-winning technology. We've won at least 5 different awards. This is a mechanical resettable plug. As mentioned, usually you have a plug that uses explosives to set itself. So you have a little explosive charge, it strokes a mandrel, expands this plug out and sets in the casing. It's there forever until you drill it out. There are some ways to mechanically reset them, but it takes a lot of doing. So we've created a way to do it off a wire line mechanically. This is what it looks like running in the well, right? So then it centralizes itself, sets some slips, and then it has some anti-extrusion devices here, right? So this prevents this packer from getting over smashed too much and not being effective. So this kind of isolates it. This is unique because these are all spring-loaded. There are 10 different sections around the diameter. So you can do this in elliptical shaped casing, any kind of deformed casing, because guess what? One of the first things you learn in mechanical engineering, which is my background, is that steel bends. You're not going to take 30,000 feet of steel and it's just going to be perfectly straight and rigid. I mean, it's going to bend, it's going to torque. So as they're running casing in the ground around these curves and bends and shape changes within the well, I mean, it gets torqued, bent, sometimes cracked, crease, all this stuff. So we can set in irregular shaped casings. And essentially the way this works and why it's called a torque plug is it's a screw, right? So basically, yeah, some of the animations aren't coming up here, but that's fine. No, here it is. There's the problem. Okay, so you literally use a screw to force this packer to expand and seal itself. The advantage of using a screw is you're telling it, you're telling the plug by its own software what it's being set in, right? So you're telling it you're setting in 5.5-inch casing of this weight and size, so it knows how many revolutions it's supposed to turn before it's set. Right? Which is not something that a regular ballistic plug does. It's you set off the charge, you hope that it's set, and then you find out later, right? With this one, which was actually discovered here in the Northeast U.S. over in Ohio in the Utica Shale, we determined that one of the benefits to this mechanical resettable plug is because you're counting the number of revolutions that it takes to set inside that casing, you know whether or not it's set prematurely or set fully or didn't, right? So in this particular well, the operator had done some defit perforating. Basically, they were pressure testing the well, right, to design their frac. They were getting pressure responses that they really didn't expect. So they were worried maybe I've got a big split in my casing and the well bore is compromised, right, which is a big deal, state regulatory issues, stuff like that. So they wanted to pressure test it. Ordinarily, you would just set a bunch of plugs or take all kinds of trips, a lot of time. We're able to go in and do it quickly, effectively. We're able to set the plug, and the first response was this, that it was clear that the plug didn't set. We were able to communicate to the client, the plug didn't properly set. We're not going to get an adequate pressure test. What do you want to do? And the decision was made, pull up 500 feet, reset it. We're able to positively determine it sets, and then go in and pressure test the well for more than an hour, which is all state regulations, right? The state requires that the well be pressure tested for at least a half an hour, although it does vary from state to state, place to place, area to area, right? But all those are required. This is what the torque plug looks like after it's been set in the well 11 times, which, as mentioned, most plugs are just, you're able to use those once and that's it. And then you either have to redress it or drill it out and it's useless. So getting into some of the more interesting stuff of what we're getting into is the FlexWell technology, right? So this is what the owner of our company really wants to get into. And this idea of making multiple lateral completions isn't a new idea, okay? But we're creating the hardware to make multiple lateral completions feasible. And why well operators like that is a few different reasons. One reason is it saves them money. To go take down a forest to make a 5-acre well pad costs a certain amount of money to do that. There's a certain amount of risk involved with state regulatory agencies. If you cause some kind of spill and the EPA has to get involved, nobody likes that type of thing, all right? So just like it used to be all vertical wells, and you'd have hundreds of wells to degas one area. Now it's all horizontal wells, and you can have one well degas the whole area, and you're saving footprint. Well, now we're taking about the option of you can drill a well, and the main horizontal be in the Marcellus formation, but then you can kick off the side of that and also put another horizontal off of the same well bore down into the Utica or vice versa. The key is the secondary lateral has to be small enough. The completion for that has to be small enough to fit in the first pipe, right? So it has to be smaller, right? So this is something that we're working on, and you can do this vertically, such as targeting the Marcellus and the Utica, or you can go in and you can make side branches off. So you can stay in the Marcellus and make some side laterals off of the main lateral to get more surface area, because as the professors can tell you, the surface area of your well is indicative of how much production you're going to get out of it over the long term. All right? So we've created all kinds of different innovative technology to go along with this. There we go. So including what we call the WellTech Data Monitor. The WellTech Data Monitor was originally created. We've got a solid steel stainless packer, a solid stainless steel packer system that replaces what people usually use rubber to do. I don't really have time in this presentation to get into the full details of it, but we created a wireless battery powered temperature pressure gauge for quality control to basically prove that our packer worked, right? But over the years, people have been trying to run fiber optic cable on the outside of their casing, right? Because they want to get data, pressure and temperature data over the lifetime of the well, right? Well, believe it or not, it's not really that easy to run fiber optic cable on the outside of a joint of casing in a 25,000 foot well. They put all these clamps and use air hammers to try and clamp it on there. They all break. It ends up wrapped around the casing, broken in half. People accidentally shoot it in half, because as you're perforating the well, opening it up to get the oil and gas out, you just shot your fiber optic line in half, and you just wasted $2 million on fiber optic line, right? So we created a short joint that's a wireless battery powered sensor that goes on a little tiny joint of pipe. You screw in between two joints of casing, right? There's two benefits to this. You don't have any control lines on the outside that risk the cement job, causing an annular area where gas can migrate to the surface and cause an explosion or environmental disaster, right? But more specifically, you can easily correlate it with what's called a casing collar locator. It's basically a way that you can tell where you're at in the well, right? Because as the joints of casing are put together, there's a little bit more thickness where the joints are compared to the middle of the piece of pipe, so you're able to see where you're at. So anyway, this particular technology, which is new, this has only came out with us in the past 12 months, can go in and feasibly alleviate a lot of the risks associated with running fiber optics, but still being able to get temperature and pressure data, right? This is just what the sensors look like. Nothing spectacular. Some pretty simple electronics. You'd be surprised how simplistic the electronics are out there in the world, folks. I mean, seriously. Everything's a voltage and current response. Doesn't make a difference how sophisticated of a piece of electronics you're talking about, whether it's this computer, some jet, space shuttle, or an oil field service tool. everything's just driven off of simple voltage current response. So what we're going to talk about now is something that, is always near and dear to WellTech, and that is innovative solutions, transforming the industry, and keeping environmentalism in mind, right? So basically, we've created what we call the WellTech frac barrier, which is it's only a foot long. It's a little short, hollow steel packer system that's related to the large packer system we have. But essentially, the point of this technology is the ability to allow an operator to go in and recycle a well, right? So basically, what a frac barrier is you have a standard well. This is a cement. This is the casing for a 5.5-inch well, which they're all over, right? Back in 2010, the frac designs, the well designs were completely different than they are today. They had much larger spacing. They would space out each frac stage as much as 500 feet. Now they're doing it every 125 feet. So in all these old wells, you have 400 feet of rock that's never been produced, right? Now, of course, some of the gas and pressure has been taken off of that as other zones were produced or other stages were produced, but you literally have untouched, unproduced rock that you can go back in and target. It's not that easy, right? So we've created a way to do it. Our way is a lot better because a lot of people use chemical diverters. You can just blow past them and all this. So anyway, we've created what we're working on now is cold work still technology. All right, cold work still is basically you don't have to heat it up beyond 800 degrees to get it to work. So we created a packer system. We run 3.5-inch tubing in. We've got this solid steel packer system, has a port open to it, right? We run in with 3.5-inch tubing, and with a common pump from the surface, you're able to go in, pressure up, and cold work that steel and expand it to inside the casing, right? Essentially what it comes down to is you have an old well that you're not getting as much production out of. We provide the ability to put hardware in there to where you have a brand new well that's a little bit smaller. So instead of having a 5.5-inch well, you now have a brand new 3.5-inch well, and you can go in and recomplete it. And the rest of the slides kind of go through, the process. I mean, essentially, this would be the schematic. I can get that to come up. Yeah, here we go. So the old well would be 5-stage well. You have 5 stages in the lateral, but they're all spaced out a couple hundred feet, and you want to go back in and target more rock. So you basically can go in off a wire line, map out where your old zones are, go back in and perforate. I don't really have the time to get into the details, but in essence what you do is you had the one stage in the old well covered that much distance. Now you're going to put 3 different stages in there. So you're going to be shooting to try and get 3 times as much production out of what you used to be getting one area of production. And the idea is, as I said, to go into the older wells and target rock that's never been produced, but it's there, right? And that way you don't have to, destroy more forest to go get more production and building another well pad. All the risks associated with that and things like that. You can go back in, recycle your old well, save time, money, risk, and get more production out of the old assets. So essentially, there's a whole process where you can run in with the tubing, then you run in, and in the stages, you're basically using our packer system to isolate the newest stages. You expand them all at once, and then you go back in, you recomplete the well, right? So probably a little bit beyond the scope of this presentation, but it's basically creating a brand new well where you go back in and you recomplete it the same way that you ordinarily would. The benefits to this is that you defer the capital expense and the operating expense of drilling new wells, locations and all this, right? You're able to boost overall recovery of the field, and the key is that you can get more out of your old assets. And then the summary is that moving forward, E-line conveyed interventions will continue to become a much more predominant part of the business. So as mentioned, I've been selling for WellTech for 8 years, and I used to be told I was nuts. Now we've worked with everyone. You name an oil and gas operator in the northeastern U.S., we've done at least one job for everyone, right? Some more than others, right? Some are still a little bit more resistant, or they've got their way and this type of thing. We've gone out there and worked with everyone. So our company has been in operation for around 22 years, which by industry standards is very young. So what you find is Chevron and Exxon and some of the major corporations, they've done studies into technology and how accepting people are of technology. And what you find is technology has to be about 20 to 30 years old before people really start to accept it. And we're just now getting past the 20-year point where people are readily accepting it as an everyday thing, right? So as time goes on, you're going to see more and more opportunities like this. And then we'll give you guys a little bit of career advice here. Basically, it's not necessarily, you can't really imagine what it's like. I mean, I couldn't, I can tell you a bunch of different stories or whatever. You're not really going to fully understand it until you get there and realize what it's like. First of all, you're going in, you have a degree. What that degree proves to somebody is that you're capable of being trained. That's it. Doesn't mean that you're the best reservoir analyst in the world because you don't even know how to run the softwares or anything like that. It means that you're capable of being trained and you were able to go get a difficult degree and not quit, right? So literally, like a recruiter explained to me one time, it's like, your first job, they give you a pencil. You don't have a clipboard or a piece of paper or anything else. You're given your pencil and you're told to go do your job. And then after a while, you get your clipboard and your paper and all that. So it's always going to be a process. Like, for example, when I went to work for Schlumberger, I'm a mechanical engineer. I know everything, of course. Everything there is to know, I already know it, right? The first thing they do is they take you, the lowest guy on the totem pole, the guy with a high school education, maybe, right, who does the worst job ever, and you're his assistant. You're the lowest guy on the totem pole. You're his assistant for 6 months, a year. And then after you've proven you can do the worst job in the company, then you get to do the second worst job in the company. And then you get to do the third worst job in the company. And then after a while, you're able to develop yourself and you get a cushy office job. Usually takes years. Even if you land a cool job with somebody like Shell, Chevron, you get, I'm going to be a reservoir engineer for Chevron and, Dubai or something like that. Guess what? They're going to make you go work on a rig for 2 months, 6 months, a year, something. You just don't get a kick back at your desk analyzing computer programs. Everybody has to do a little bit of time in the field. Some more than others. All right? So anyway, we'll just go through the list here. I mean, as mentioned, safety and environmentalism is paramount in the industry. It's the first thing you do. Every 12 hours, there's a safety meeting on location, right? You have to be there. They're going to talk about the exact same thing every safety meeting because it's all written in blood. The reason why they're talking about it, it happened. Somebody died, somebody got injured. It's important. Every 12 hours, right? Sometimes more than every 12 hours. If there's a change, then you have another safety meeting to talk about what just changed, right? And then you have another safety meeting about the safety meeting and so on and so forth. A serious violation of safety or environmental policy will result in your termination, possibly getting you involved with legal proceedings from the state. Right? There's a chief operating officer for Gulfport Energy was at a vendors meeting. A lot of companies, they have their vendors come in. And basically this chief operating officer is telling us a story about he's been spending the past week with the state of Ohio basically being like, you guys better get it together or else, right? And he's, they're sweating it because he's got a regulation book this big and he has to know everything about it. And if his company violates this, he's the one held responsible, okay? And that's one of the key things, right? If you're a drilling engineer sitting at a desk in Amsterdam, right? Somebody 300 miles away working on a rig that you have no direct control over, they make a mistake, you can lose your job. Like that. Managers, out the door, all right? Because as your job as a drilling engineer is to manage the overall operation and make sure people are properly trained, you're hiring the right contractors, right? You don't get to go hire your brother-in-law and stuff like that. There's contractor supplier management and all this stuff, right? So literally, an accident that happens 500 miles away from your location, you have very little to no control over, can cost you your job because it's a violation of policy and you are responsible for that end to end, and you need to get out there. You need to go take that 500-mile trip and go hang out on the rig for a little while, right? So that being said, though, mistakes are expected and tolerated as long as it's a minor mistake, right? They'll tell you, you're going to make a mistake. There's no way you're going to do this job for more than 6 months and not make 5 mistakes, right? Just try not to make this mistake, and that mistake, and it's all good, right? Whenever you start out in the field, you also have the ability to just get the heat off of your back. You call your manager. You're like, hey, manager, I just made the mistake. Mistake number 4 you said to never make. Well, we just made it, right? And then it becomes your manager's responsibility, and you're still gonna, get the heat and some pressure or whatever. But the manager, the whole management system comes in, it takes over, and alleviates that problem, right? Then, as mentioned, you're gonna witness the impossible. It's never, ever supposed to happen. It's literally impossible. There's no way this could possibly be happening, yet we're all standing here looking at it today. Back whenever I was an open hole logging engineer, running geological logs, we worked on rigs for days at a time sometimes. We were waiting on a rig to pull some pipe out so we could run back in with our logging tools. So, these rigs are able to pull 100,000 pounds, 150,000 pounds of force. I mean, a lot, more than you could possibly imagine, right? And apparently what was happening is there was a little tiny 1/8 inch thick piece of steel, what's called a centralizer, right? That was hung up on a piece of rock somewhere. It's the only thing it could possibly be. Everybody's just like, this is impossible, it's impossible. It's not possible for that little tiny piece of steel to be holding everything up. When they finally did get the pipe out of the ground, the centralizer was ripped apart. That's exactly what was happening, right? So the impossible is going to happen. You're going to witness it all the time. Technology moves fast, and you've got to be willing to change, right? What you learn today is going to be completely different. The whole industry's changed. In the 8 years I've worked for WellTech, the whole industry's changed. If you go back to 2004, whenever I started with Schlumberger, it's changed even more so, because we were still doing vertical wells at the time. There were these mythological horizontal wells out there in the world, but nobody ever thought they were going to see them, right? 5 years later, it's the newest thing all over the country. People were drilling deeper, faster, and all that. One of the biggest things is, and one of the guys who recruited me, an Austrian guy named Mishka with Schlumberger, basically said, what his exact words out of his mouth were, I speak my mind, and I'm surprised they haven't fired me yet, right? But what you find is that if you can respectfully speak your mind and not back down when you know you're right and you know you're justified and you can back it up, then you'll go far and fast within organizations. Because most people are intimidated by big, corporate level executives, or the whole oligarchy of, the corporation. This is the greatest corporation in the world. How could little old me question the knowledge of this vast corporation and stuff like that? But when you're right and you have evidence to prove it, you need to be able to respectfully stand up to these people. And when you do, you can convince them that you're right, and you'll go far, you'll go fast, you'll be offered opportunities to be management, stuff like that. Now, that in mind, you do have to apply strategy and pick your battles sometimes, right? You just can't go in, jump up on the desk, beating on it, yelling and screaming. You have to, be able to get your point across. And then again, in the end, basically spend as much time in the field learning as much as you can. Everybody's like, yeah, sure, whatever, man, great. But really, we were talking about this at lunch, right? As an engineer, right, you're going to get a hard time because you're the engineer, right? Like I said, you're going to be going to work with people, being the assistant to some guy who never even graduated high school, right? And he doesn't care that you have an engineering degree. Could care less, right? As a matter of fact, he doesn't like you because you do have an engineering degree, right? Moreover, absolutely, right? So the point is sometimes these people occasionally play tricks on people. Like if you've ever done an internship, a big thing on a rig is there's something called a V-door. A V-door is just a platform that goes from what's called a catwalk, and it's a ramp that delivers equipment, a ramp that you drag stuff up onto the rig floor with, right? It's called a V-door, all right? Nobody knows why exactly it's called a V-door. It's a long story. Anyway, the point is whenever you first go to work on a rig, everybody's like, hey, go find the keys to the V-door. So you're the newest guy there, clean coveralls, everything. You're walking around, asking people, hey, where can I find the keys to the V-door? And people just laugh at you like, pfft, and just turn around and walk away. And you're like, well, how come he's not answering me? And you go chasing after him. Excuse me, sir. Where's the keys to the V-door? Right? And they're just like, oh. And then finally, after you spend like 7 hours wandering around the rig getting laughed at, and people just ignore you, somebody's like, hey, new guy, there's no such thing as keys to a V-door. That's the V-door. There are no keys. Now sit down and shut up. Have a sandwich or something, right? Another one is hydraulic AIR, right? So go find me a big bucket of hydraulic AIR, right? Which is just air. So go get me a bucket of air. And people, so literally. And I mean, just being an engineer, right? Engineers are naturally critical thinkers, so they're wandering around. Hydraulic, I know hydraulics. Now I know a lot about hydraulics. So because that area and inertia and radius, stuff like that. So it's going to happen. So the more time you spend in the field and the more you get involved in the operations and see the mistakes and make the mistakes, right? I mean, some of the reasons that I'm successful at what I did, I messed up a bunch of times, right? I mean, I had a manager with this one time, we messed up this wireline spool so bad, right, that basically it's supposed to be nice and smoothly, neatly wrapped. We managed to actually, I don't know. Anyway, we had a manager show up taking pictures of how bad of a job we did. They're just like coming from hundreds of miles away, like, I can't believe you boys did this. And we're like, you should have given me a day off or something like that, right? So I mean, like I said, you're allowed to make a certain amount of mistakes, right? You're going to get in trouble with some of the mistakes you make, part of the business, right? They don't want people that don't know how mistakes, and people try to pull tricks on you and stuff like that. So you've always got to be careful. And the more you know, the better off you are. And that's basically it. If you guys don't have any questions, or if you do have any questions, let me know. And I appreciate your time, and good luck out there. You're getting into the industry at a good time. What's that?
Would you say that your designs are more unique than your competitors?
Well, we do have some competitors, but the interesting thing about our technology is we have two primary competitors. One competitor that we have, the only reason they exist is because when Statoil gave our company money up front to start up their business, the agreement was we're going to give you this money because we like this technology, but at the same time, we don't want to just hand you, let you corner our market on the technology. So we're going to bring this other manufacturing company in. Since you just can't manufacture your own stuff, we're going to give you the money, bring this manufacturing company in. You have to give up a certain amount of your rights to your first generation technology to this manufacturing company, right? So one of our competitors exists out of that, but they're limited that they only have the rights to use our first generation technology. We're on our third generation, developing our fourth. So ours is much better. So they have a similar technology, but ours is better, faster, more sophisticated. Now, the other main competitor we have is Schlumberger, my former company, one of the world's largest technology companies in the world, and they mimic everything we do. We came up with a tractor first. I mean, our owner had a patent on the technology, right? So Schlumberger couldn't use that exact technology. They had to develop their own technology, and their own technology, the way they did it, ours is electric over hydraulic. So hydraulic is more robust in a hazardous environment, such as a well. Theirs is all electric. Electric is much more impacted by temperature. So when it gets in a hotter well, it degrades and fails easier, whereas our hydraulics won't, right? So, yeah, I mean, we've got the advantage, right? So, we bail our competitors out. So even Schlumberger, as big and as prestigious as they are, we are called to bail them out occasionally. As a matter of fact, 2 weeks ago, we were almost going to have to go bail them out, but they dragged their feet enough that they were able to get some replacement tools on location or something like that, right? This kind of thing. But we're continuously developing it. Some of the most of the technology, with the exception of the last couple of things, are relatively old technology. We've got some other tricks up our sleeve, right? I couldn't get into all the technologies that we do just because it's beyond the scope of the presentation like that, and this type of thing. So, yeah, we're not afraid of competition. Yes?
What's the biggest weakness of your product?
Well, the biggest weakness of our product is that, we are limited to wireline-based operations, right? So as mentioned, we can't go do everything coiled tubing can do, but we can do 70%, 80% of what they can do, safer, easier, faster, right? But, we would like to be doing, work more consistently on every well, right? Which isn't necessarily the case, right? Like, for example, they need perforating guns on every single well in the water, right? Our technology isn't to the point where it's needed everywhere all the time, but it has its place, right? And what you find is this is how the technology is changing, right? In a short amount of time. In the 8 years I've been with WellTech, a pressure-activated toe sleeve didn't exist. So to get the first stage of the well open, they had to use coiled tubing and push all these pipes down to the bottom of the well because you couldn't pump down yet, right? Until you opened the well. And we used to do that. Instead of them using coiled tubing, we would go down and perforate the first stage and be able to pump down. Well, then, you had the toe sleeves come about, right? And things like that. The point of all this is for an oil and gas operator, an ideal well right now, they will never have to do an intervention in that well. The toe sleeve opens perfectly, which they don't. We still do the exact same number of toe perforating jobs that we've always done. It's just we don't necessarily know about them in advance as much anymore. But in an ideal well, the toe sleeve's going to open up. They're going to be able to pump down every stage of guns perfectly without any issues. Everything's going to be fine. They're going to be able to frack every stage, and they're never going to have the formation close. Because as you're fracturing, right, you have like a shut-in pressure record, and sometimes the formation just closes up, slams shut, and you can't pump any more sand into it. It's what's called screening out, sanding out. So in those circumstances, you have to get that sand out of the well to continue back on with the fracturing operation. And you usually use coiled tubing or tubing of some kind to clean that out, circulate that sand out, and get it to where you can pump back into the well, right, and open the formation, okay? And anyway, in an ideal well, that's never going to happen, right? But an ideal circumstance never occurs, right? So people screen out regularly. So people are trying to get away from wireline interventions, coiled tubing interventions altogether, right? And this has happened in the past 8 years. So technology happens fast. I hope that answered your question. Okay. What else were you looking for then?
No, I'm just curious because my dad has a business, so I get him to sell his product.
Okay.
So whenever I hear a salesman, you always see the benefit. So I'm always curious how well they trade there.
Well, that's a very valid point, and like I said, that is one of our weaknesses. That we're limited in the volume and the amount of power that we have behind us, right? That's actually a very valid question. And as a salesperson, you have to be prepared for it. Basically, if you can't explain your weaknesses, your number one failure and stuff like that, then people they lose trust in you and they don't want to buy. So, like more directly, what our number one failure is electronics. So we have a 98% success rate. All right, we consider anything below 96% success rate a failure, right? Which for some of our clients, if we have one failure, it completely blows our statistics to like 92%, which we consider to be unacceptable, right? We want it to be 96 or better, right? But out of the failures that we do have, it's related to electronics. typically because there's some kind of temperature effect, right? Or what you find is whenever you're dealing with mechanical equipment, as a mechanical engineer, you learn how to design with a planned life cycle for your product, right? So if you want something to last forever, it's going to be very expensive and different, right? So you build something planning that this is going to last me 600 hours, 600 runs, 600 years, whatever. There's some value aside the life cycle of that product, right? You monitor the life cycle of that product, and before its life cycle's over, you replace it, right? So sometimes we have components that fell before they were supposed to, right, for a variety of different reasons. And that's one of the largest failures that we would have, right? But it's a very small percentage, so we can tolerate it.
Thank you very much.
Thank you. I left some brochures up here. I didn't bring enough cards for everybody, or they're in my Jeep still. So I left a few cards, and they know how to get a hold of me. And there's some
So our student
information there.
and our speakers.